Welcome, dear traveler, to the Sleep Enigma, where the stars are bright, the science is gentle, and the only thing faster than the speed of light is how quickly we hope you'll drift off to sleep. Tonight, we're taking a slow, dreamy voyage through our cosmic neighborhood, a quiet meander past 8 very different worlds, all orbiting the same faithful star. From the blistering cliffs of Mercury to the icy winds of Neptune, each planet has its own personality, quirks, and charm. And don't worry, you won't need a spacesuit, just a comfy pillow and perhaps a cup of tea. Now, I should offer a small, polite warning. While I do hope this video helps lull you into a lovely sleep, there's always the risk it might be too interesting. If you find yourself lying awake wondering how Uranus ended up sideways, or why Jupiter is basically a giant storm in a tuxedo, well, at least you'll be learning something on your way to dreamland. Before we begin, if you enjoy these gentle, sleepy journeys through science, it would mean a lot if you could tap the like button and perhaps subscribe so you don't miss future trips through time, space, and everything in between. It's free and helps this little starship keep floating. Also, if you're still awake, which is entirely optional, I'd love to know where you're listening from and what time it is for you, right? Now the city lights twinkling outside your window, the distant hum of the city, a gentle lullaby. Or maybe you're nestled in a cozy cabin in the woods at midnight. The only sound, the rustle of leaves against glass and the soft crackle of a dying fire. Whatever your place and hour, wherever you are in this vast, interconnected world, you are profoundly welcome here. There's no rush, no test at the end, just a slow, soothing wander through the universe where you can drift and doze at your own pace. Now, close your eyes if you like. Let your breath deepen and slow. Breathe deeply and let's begin our journey. 1 star, 8 curious worlds, and you floating gently in between. Our journey begins with the sun, the golden heart of our cosmos. A star in gentle slumber. Let us begin where everything in our corner of the cosmos does, with the sun. Imagine, if you will, a truly blinding sphere of pure, incandescent fire, so utterly vast and immense it could effortlessly swallow over 1 million Earths whole, leaving vast, empty spaces within its fiery embrace. It hangs in the cosmic void, an astonishing 400 times farther from us than our own familiar moon. And yet, incredibly, it is also precisely 400 times larger. This exquisite, almost miraculous cosmic coincidence is why, to our human eyes gazing up from Earth, the moon and the sun appear to be of identical size in our sky, a perfect fit during a total eclipse. But make no mistake, dear traveler, the sun is no modest ball of light, no gentle lantern offering a faint glow. It is a gargantuan furnace, a churning, roaring engine of fusion, a titanic powerhouse that pulses with unimaginable energy, and it is the undisputed gravitational anchor that holds our entire solar system together, like a careful, infinitely patient parent, gently yet firmly, guiding 8 wildly different, restless children in their endless, graceful, cosmic dance around its fiery being. The sun is what astronomers categorize as a yellow dwarf star. The name dwarf feels almost like a cosmic jest, doesn't it? Especially when you contemplate its colossal physical dimensions, an incredible 860,000 miles, 1.39 million kilometers across. To put that into perspective, you could line up 109 Earths side by side just to span its diameter, deep within its fiery superheated heart every single second. An almost incomprehensible number of hydrogen atoms are being pressed together under unimaginable pressures, reaching temperatures and densities that defy earthly comprehension. In this extreme crucible, they fuse to form helium. This incredible process, known as nuclear fusion, unleashes a torrent of pure energy that slowly, powerfully, yet relentlessly travels from the sun's fiercely hot core through its vast, turbulent layers to its shimmering, boiling surface. And then, from that surface, it bursts outward, radiating into the cold, silent vacuum of space. It's this very energy that reaches us here on Earth as the gentle warmth on our skin, as the life-giving sunlight that bathes our world, and yes, as that subtle, nagging sense of remember to wear sunscreen. It takes that precious light, on average, a little over 8 minutes to traverse the immense distance and reach us here on Earth, which means when you gaze at a beautiful, serene sunrise, you're not actually seeing the sun as it is at that precise instant. No, you are looking 8 minutes into the past at a warm, golden ghost of a moment that has just slipped away from the present, a timeless echo in the sky. The surface of the sun, often called the photosphere, isn't solid like the ground beneath your feet. Instead, it's a boiling, tumultuous, incredibly active sea of plasma, a superheated, ionized gas where temperatures hover around a scorching 10,000 degrees Fahrenheit, 5,500 degrees Celsius, but venture even deeper into the sun's very core, and the heat becomes truly unimaginable, a staggering 27 million degrees Fahrenheit, 15 million degrees Celsius. That's a temperature so extreme, so utterly beyond our sensory experience, that it melts all known substances and creates conditions unlike anything we can replicate on Earth. It is, perhaps, hotter than anything you've ever felt, unless, of course, you've tried sitting in a car in Multan in July with the windows rolled up and the air conditioner off. Though even that searing experience pales dramatically in comparison to the sun's heart. The sun isn't a static, unmoving ball either. It rotates, though not like a rigid body made of solid rock. Because it's composed entirely of gas and plasma, its equator actually spins noticeably faster than its poles. A full rotation takes approximately 25 Earth days at its bustling equator, while near the more leisurely poles, it can stretch to around 35 days. Picture, if you will, a colossal, cosmic, spinning pancake, where the syrup at the very center moves with incredible swiftness, while the edges lag behind, slowly trailing, a messy, glorious, and intensely magnetic pancake of fire. Speaking of magnetic fields, the sun's magnetic activity is nothing short of dramatic, constantly shifting and evolving. It creates those mysterious, dark blemishes that appear on its surface, which we call sunspots. These are, in fact, cooler regions where incredibly tangled, powerful magnetic field lines break through the photosphere, suppressing the convection of heat from below. And then there are the truly spectacular phenomena, the solar flares, massive, explosive eruptions of energy and radiation that can shoot superheated charged particles hurtling outward into the solar system, often directed toward Earth at incredible speeds. Sometimes, these energetic solar storms can gently, or not so gently, depending on their intensity, interfere with our satellites in orbit, or even cause the breathtaking auroras, those dancing, ethereal curtains of light, like cosmic paintbrushes, that illuminate the skies near Earth's polar regions, known as the aurora borealis in the north and aurora australis in the south. The sun, therefore, is not just a steady light. It is always bubbling, always burping, and occasionally throwing spectacular, fiery tantrums that ripple and echo across the entire solar system. And yet, despite all this raw, untamed power, despite its fiery volatility, we owe our very existence, our quiet, comfortable lives, to its serene, steadfast consistency. The sun has been shining steadily, reliably, for approximately 4.5 billion years, a constant beacon of light and warmth. And, reassuringly, it's expected to continue its stable fusion for another 5 billion years or so before it begins its grand, slow transformation into something entirely different. Rest assured, it won't explode in a violent, catastrophic supernova. Our sun simply isn't massive enough for that kind of dramatic, self-destructive finale. But eventually, in the far distant future, it will swell into a colossal red giant, growing so immense that it will likely encompass Mercury, Venus, and perhaps even Earth, turning our familiar skies into a fiery reddish glow before gently shedding its outer layers into space in a sort of slow, graceful, cosmic farewell. What will be left behind? A tiny, incredibly dense remnant called a white dwarf, a cosmic ember no bigger than Earth, but holding the staggering mass of the entire sun, slowly fading into the profound cosmic memory, a silent, cooling echo of its former glory. But that, dear traveler, is a long, long, long time from now, a story for a distant future epoch. Tonight, the sun remains our steadfast, golden star, glowing gently and faithfully on the far side of our planet, casting the soft, ethereal moonlight on your window, fueling the vibrant growth of plants, warming the vast, life-filled oceans, and gently, yet powerfully, steering the intricate, predictable orbits of every object that proudly belongs to its immense cosmic family. It's truly hard to overstate just how dominant the sun is within our solar system. It contains an astounding over 99% of all the mass in this entire cosmic neighborhood. That incredible, almost unfathomable percentage includes all the planets, all their numerous moons, every single asteroid, every graceful comet, and every tiny, intrepid, wayward space probe we've ever launched from Earth. All of it, everything you can possibly imagine in our solar system could fit inside the sun with vast, empty room to spare. Even mighty Jupiter, a colossal gas giant that could comfortably swallow Earth over 1,000 times, is dwarfed into utter insignificance by the sun's sheer, overwhelming scale. And yet, for all its immense size, its tireless power, its fundamental importance, we rarely stop to truly appreciate it in our daily lives. It rises and sets, or rather, we, our beloved Earth, spin and dance in its light and its familiar. Constant presence often becomes just background noise, an expected part of our daily rhythm, taken for granted. But try, for a quiet moment, to imagine a sky without it. No radiant sunrises, no warm afternoons, no predictable seasons, no refreshing weather, and most tragically, no life, just cold, dark, unending silence. stretching across the void. There's something profoundly comforting, isn't there, in its sheer constancy, its unwavering presence. The very same sun that warmed the backs of ancient colossal lizards 100 million years ago as they basked on prehistoric rocks is the very same sun that glints off modern skyscrapers today, casting long shadows in molten. The photons of light that touched your skin this morning were born in the fierce, hot core of the sun, literally thousands of years ago, slowly crawling their way through its dense layers to its surface before racing across space at the astonishing speed of light to reach your eyes. Even time itself, in a profound way, bends to the sun's will. Our calendars, our definition of a day, our very biological rhythms, from waking to sleeping, they all revolve, quite literally, around this magnificent, tireless star. We wake with its light, greeted by the dawn. We rest in its comforting absence, embraced by the night. And from time to time, we gather, hushed and awestruck, to watch it briefly disappear behind the moon in those rare, mesmerizing total solar eclipses that remind us just how small and how interconnected we are in the grand, silent ballet of space. In ancient times, people didn't just appreciate the sun. They revered and worshipped it as a deity. They built vast, intricate temples precisely aligned with its rising and setting points, monuments to its power. And they told rich, intricate stories of gods and goddesses who rode golden chariots across the sky, bringing light and life. Today, we understand the profound science behind it all, the physics, the nuclear fusion, the gravitational laws. But perhaps that primal sense of awe, that deep, unspoken wonder, has not entirely left us, nor, indeed, should it, because while our sun is just one of billions of stars scattered across the vast expanse of the Milky Way galaxy, to us, for every living thing on Earth, it is unequivocally home. It is everything. So, as you lie there, dear traveler, drifting further and further into a peaceful, profound rest, know that above you and all around you, the tireless ancient light of the sun keeps traveling, falling upon frozen moons in the outer reaches of the solar system, glowing through Saturn's majestic, icy rings, illuminating distant comets on their long journeys, and warming our precious little planet just enough for water to stay liquid, for life to flourish in all its intricate forms, and for dreams to grow, blossoming in the quiet of the night. The sun will still be there in the morning, a reliable friend, still burning, still shining, still anchoring every single orbit in its gentle, fiery, unwavering embrace. You don't need to understand every scientific detail, every complex calculation, every quantum interaction to feel its profound, comforting presence. Just breathe in the warmth, even now. Feel its distant, constant power, and let it gently lull you into a state of deep calm. You are an integral part of this magnificent cosmic system, a stargazer, a sleeper, a thinker, resting under a vast, ancient sky. And that sky, though immense and timeless, is lit by a star that, in its silent, profound way, knows your name, knows your place. First stop, Mercury, the speedy, scorched, and silent messenger. Now that we have truly met the sun, the grand, radiant conductor of our celestial symphony, having felt its distant warmth and grasped its immense power, let's drift gently, slowly, but with purpose, to the very first planet in line, Mercury, If our entire solar system were a grand cosmic racetrack, Mercury would undoubtedly be the sprinter. Not just any sprinter, but the one who, with boundless energy, insists on doing laps at an absolutely breakneck speed, always chasing the sun, perpetually basking in its blinding, relentless presence, and never quite managing to truly cool down. It is, without a doubt, the closest planet to the sun, orbiting at an average distance of about 36 million miles, 58 million kilometers. To put that into perspective, that's less than half the distance between the sun and our own familiar Earth. A truly cozy neighbor, indeed, if, that is, you consider blistering, unshielded radiation and searing, utterly silent desolation cozy. It's a world of extremes. Mercury is the smallest of the 8 major planets in our solar system, a tiny pebble compared to the giants. It's only slightly larger than Earth's own natural satellite, the Moon. In fact, if you were to ever see them, side by side, floating in the cosmic void, their similar size and grayish hue might easily lead you to mistake one for the other. But Mercury isn't a moon. It's a planet in its own right, and it isn't especially friendly either. It's more like a battered, ancient warrior, scarred and scorched by eons of solar assault and countless impacts, and perpetually, eerily silent, holding its secrets close. The surface of Mercury is a profound testament to its long, harsh, and brutal history. It's utterly covered in a vast, intricate tapestry of craters, ranging from tiny pockmarks to colossal basins, alongside towering, jagged cliffs and vast, ancient plains of hardened lava. It bears the undeniable, enduring marks of billions of years of cosmic collisions, much like our moon. But perhaps even more extreme and numerous, there is virtually no atmosphere on Mercury, no protective blanket of air to cushion a meteor's fiery, high-speed impact. So, when something strikes Mercury, it hits with brutal, unmitigated force and leaves a deep, lasting impression, a permanent scar that ensures for an eternity, with no wind or water to erode it away. Imagine a world where time doesn't gently wash things away, where every ancient wound, every colossal impact crater remains visibly etched into the very face of the planet for untold eons. Mercury is, in essence, a planet that remembers everything, its surface a cosmic, historical record. Now, given its extreme, almost perilous proximity to the Sun, you might naturally expect Mercury to be the absolute hottest planet in our solar system. But, strangely enough, it's not. That dubious honor, surprisingly, goes to Venus, which we encountered just a moment ago. While Mercury certainly does get incredibly hot, temperatures on its sun-facing side can soar above a blistering 800 degrees Fahrenheit, 430 degrees Celsius, hot enough to melt many common metals like lead and tin. It also experiences unimaginably, brutally cold nights, without a thick, insulating atmosphere to trap and redistribute that scorching heat around the planet. The temperature on Mercury's night side can plummet to a chilling -300 degrees Fahrenheit, degrees Celsius. That's an astonishing, almost incomprehensible swing of over 1,000 degrees Fahrenheit, 550 degrees Celsius, between day and night. You would certainly need quite a flexible and incredibly advanced wardrobe, perhaps even a spaceship with a built-in climate control system to even consider living there. And speaking of day and night, the passage of time on Mercury is wonderfully, utterly bizarre and unique. A single day on Mercury, meaning the time from one sunrise to the next, takes an astonishing 176 Earth days. That means if you were to stand patiently on its desolate, cratered surface and wait for the sun to rise, slowly arc across the pitch-black sky, and finally set again, you would literally be waiting for almost 6 Earth months for a single solar day to complete. And here's where it gets even stranger. A cosmic quirk, a year on Mercury, a complete orbit around the sun, only takes 88 Earth days. Yes, you heard that right. The Mercury year is actually shorter than the Mercury day. This utterly peculiar, counterintuitive situation is thanks to a phenomenon called spin-orbit resonance, a gravitational ballet between its slow spin and its rapid orbit. Mercury rotates very, very slowly on its axis. It turns on its axis just 1.5 times for every single trip it makes around the sun. It's like a planet that simply can't decide whether to be incredibly fast or incredibly slow. So it settles for doing both at once in a most peculiar, gravitationally dictated rhythm. If Mercury were a person, it might be the type who sprints to the grocery store with incredible athletic speed and then proceeds to spend 3 hours leisurely, slowly wandering the aisles, lost in thought. And if you were, hypothetically, standing on Mercury's surface, assuming, of course, you could miraculously survive the extreme temperatures, the relentless, unfiltered solar radiation, and the utter, life-depriving lack of oxygen, you would witness some truly peculiar sights in its stark, airless sky. During certain times of its highly elliptical orbit, the sun would appear to rise, then briefly set again for a short period, and then, quite unexpectedly, rise once more before continuing its path across the sky. This strange double sunrise phenomenon is all due to Mercury's unique, highly elliptical orbit, and that odd, slow spin, creating a warped sense of time and perspective. The sun, it seems, plays an endless, cosmic game of hide-and-seek with Mercury, and its sky never behaves quite the way you'd expect, defying all earthly logic and intuition. There is virtually no weather on Mercury. No clouds ever drift across its perpetually black sky. No rain falls to cleanse its dusty surface. No wind whistles through its ancient craters. Just an eternal, profound, eerie silence. The only things that visibly move are the long, sharp shadows, which crawl slowly, painstakingly, across the desolate landscape as the distant, yet overwhelming, sun makes its strange, measured journey overhead. Despite this eerie stillness and its seemingly barren exterior, Mercury isn't entirely a dead world. Beneath its scarred, solid surface lies a surprisingly large metallic core. In fact, scientists believe this massive core makes up about 85% of the planet's entire radius, a far greater proportion than Earth's core. This large, churning core generates a weak but detectable magnetic field, which was a truly surprising discovery to researchers, as smaller planets are often thought to have inactive cores. It's only about 1% as strong as Earth's, but its mere persistent presence was enough to puzzle scientists for years, hinting at ongoing internal activity deep within its heart. And there's even more mystery that captivates astronomers. Some specific regions near Mercury's poles are permanently shadowed, never seeing the direct light of the sun. These areas are hidden from the sun's harsh, relentless rays by the towering, deep walls of craters. In these eternal, frozen shadows, surprisingly, scientists have detected what they strongly believe is water, ice. Yes, ice, on the nearest planet to the sun. It's a truly wonderful contradiction, isn't it? A blazing hot, incredibly dry, sun-baked planet with unexpected, hidden pockets of eternal frost, ancient water frozen in perpetual darkness. A remarkable secret kept in the dark corners of the solar system. Humanity has sent spacecraft to Mercury, though not many, given the incredible technical challenges involved in reaching and orbiting such a close neighbor of the sun. The first brave explorer was NASA's Mariner 10 in the 1970s, which performed multiple flybys and managed to photograph less than half the planet's enigmatic surface, leaving much unexplored. More recently, NASA's Messenger mission, short for Mercury Surface, Space Environment, Geochemistry, and Ranging, spent a remarkable 4 years orbiting Mercury from 2011 to 2015, giving us our most detailed, intimate view yet. Messenger revealed incredible things, strange, shallow hollows in the surface that appeared to be sublimating, surprising chemical compositions of its crust, and those tantalizing hints of polar ice that confirmed earlier theories. And there's still more to come, as our thirst for knowledge is insatiable. The European Space Agency's ESA Bepi Colombo mission, named after the brilliant Italian scientist Giuseppe Colombo, who, in the 1960s, helped explain Mercury's peculiar spin-orbit resonance, is currently on its long, complex journey to the planet. It's a sophisticated, two-part spacecraft, a joint mission between ESA and the Japan Aerospace Exploration Agency, JAXA, expected to arrive in orbit around Mercury in the early 2030s, poised to deepen our understanding of this elusive, fascinating, and extreme world. Mercury's name itself comes from Roman mythology. Mercury, the swift messenger of the gods, known for his speed and cunning. It's a fitting name, in a way, for a planet that races around the sun with such incredible velocity, always moving quickly, always silent, carrying its ancient, unspoken secrets. It's the celestial sprinter who whispers rather than shouts, the ancient traveler who never truly stays in one place for long. And despite its close, fiery proximity to the sun, Mercury is notoriously difficult to observe from Earth, a shy, elusive target. It never strays far from the sun's blinding glow in our sky, always appearing just before sunrise or just after sunset, hugging the horizon in brief, golden flashes against the twilight. For centuries, many people never saw it at all, a hidden gem obscured by the sun's brilliance. And even today, it's easy to miss unless you know exactly where and when to look. A challenge for even dedicated stargazers. But now, in your profound imagination, you've been there. You've wandered its cratered plains, felt the vast emptiness of its non-existent sky, witnessed the bewildering double sunrise, and shivered in the silent, perpetual shadows of its polar craters. Mercury is not a planet we dream of visiting for vacations, not a likely home for future human settlements, certainly not a place for a comfortable stay, but it is, undeniably, a world with its own quiet dignity, a testament to resilience, fast, strange, and incredibly enduring. So let us drift onward, gently warmed ever so slightly by the distant, receding glow of Mercury's sun, and carry with us the memory of a planet that spins slowly, orbits quickly, and never stops whispering its ancient, cryptic secrets into the cosmic wind, a silent testament to the universe's endless variety. Next stop, Venus, Earth's fiery, enigmatic twin, a portrait of a runaway world. Now we come to Venus, a planet, often, and perhaps deceptively, called Earth's sister. On paper, at first glance, they appear strikingly similar, alike in size, in mass, and even in their basic, rocky composition. This superficial resemblance has, for centuries, fueled our fascination, painting a picture of an almost identical sibling. But make no mistake, dear traveler, this celestial sister has a fearsome, volcanic temper. Imagine our beloved Earth after a particularly, spectacularly bad day, draped in thick, suffocating clouds of corrosive gas, perpetually obscured from view, seething under crushing atmospheric pressure so immense it could flatten a tank, and blazing with heat hot enough to melt the very lead in your pencils, or even the rocks beneath your feet, turning them into shimmering, molten rivers. That, my friends, is Venus. It's exquisitely beautiful from afar, a mesmerizing, brilliant, creamy jewel hanging in our sky, reflecting sunlight with incredible intensity, often outshining every star. But up close, it is absolutely, utterly inhospitable, a true hellscape, like a gorgeous, enticing key lime pie that, upon closer inspection, turns out to be made entirely of molten lava and pure, unadulterated, scorching rage. Venus is the second planet from the Sun, positioned just beyond Mercury's swift orbit, and it is, indeed, only slightly smaller than Earth, with a diameter of about 7,521 miles, 12,104 kilometers, making it almost Earth's exact twin in terms of size and density, almost like planetary twins born from the same cosmic blueprint. But that, unfortunately, is precisely where the comfortable similarities end. While our Earth is wrapped in a breathable, life-giving atmosphere and adorned with vast, shimmering, life-sustaining oceans, Venus is tragically blanketed in thick, swirling, perpetual clouds of sulfuric acid with an oppressively dense atmosphere. It's as if Earth decided to wrap itself in a toxic, suffocating sauna, and then, with malevolent intent, crank up the heat to absolutely unbearable. Holds the terrifying, undisputed title of the hottest planet in the solar system. Yes, that's right, even hotter than Mercury, which physically orbits much closer to the Sun. This is because Venus's incredibly thick, carbon dioxide-rich atmosphere creates a devastating, irreversible phenomenon known as the runaway greenhouse effect. This dense, atmospheric blanket acts like a superficient insulator, trapping heat so astonishingly effectively that surface temperatures can soar above a blistering 860 degrees Fahrenheit, 460 degrees Celsius. That's a temperature hot enough to melt many common metals like zinc, tin, and even lead, turning them into shimmering molten puddles on its surface, which, let me reiterate, is absolutely, profoundly not advised. Even with the most advanced protective gear, you would be simultaneously cooked alive, crushed flat by the immense pressure, and then, to add ultimate insult to injury, slowly dissolved by the corrosive, acidic air. Definitely not the most welcoming travel destination for a leisurely stroll. or even a quick stop to take a selfie. The atmospheric pressure on Venus is another nightmare entirely. On Earth at sea level. To give you a better, more visceral sense, that's roughly equivalent to the crushing pressure you'd feel if you were nearly hardened submersibles dare to venture. So, if the unimaginable, searing heat doesn't utterly destroy you, the relentless, suffocating pressure most certainly will. Venus is like a slow-cooking pressure cooker, simmering for billions of years, perfectly perfecting its infernal recipe. With no escape valve, only a constant buildup of unbearable conditions. And then there's the atmosphere itself. Those thick, yellowish, perpetual clouds are not just any clouds. They are literally filled with tiny, highly corrosive droplets of sulfuric acid around the planet at speeds of over 200 miles per hour, 320 kilometers per hour. But down on the actual surface, surprisingly, the air moves sluggishly, heavily, and remains eerily still, a thick, super-dense fluid, as if it's too tired to even bother after pressing down with so much immense weight. Venus also spins in a very unusual way, a true anomaly among the planets in our solar system. First, it rotates extremely slowly on its axis. This means that a single day on Venus, from one sunrise to the next, if you could see it, is actually longer than its year, which lasts around 225 Earth days. An astonishing cosmic rhythm that defies our everyday understanding of time, including Earth. This is known as retrograde rotation. So, if you were watching the sun from the surface again, from inside your hypothetical, heavily reinforced survival capsule, perhaps powered by thoughts of a cooler, more pleasant world, the sun would inexplicably rise in the west and then slowly set in the east. Imagine a slow, backwards dance under an eternally acidic, sulfurous sky, a truly alien and disorienting experience. Scientists believe that Venus may not have always been this way. Billions of years ago, the young Venus might have had vast, shimmering oceans, or at the very least, a much more temperate, hospitable climate. But something profound and catastrophic changed, perhaps intense, prolonged volcanic activity, releasing vast amounts of greenhouse gases, or a slow, relentless accumulation of carbon dioxide as its primeval oceans evaporated and the planet's climate spiraled tragically, uncontrollably, into its current terrifying inferno state. Studying Venus is more than just a fascinating planetary curiosity for scientists, a chilling warning echoing across the cosmos for our own Earth. It is, after all, the third brightest object in our sky, a sparkling jewel against the pre-dawn glow, or the captivating evening star just after dusk, a luminous beacon against the deepening twilight. For ancient civilizations across the globe, in the sky marked calendars, guided mythology. The Soviet Union's ambitious Venera program in the mid-20th century was a pioneering effort, achieving the incredible feat of being the first to successfully land spacecraft on Venus, starting in the 1960s and continuing through the early 1980s. Venera landers provided the very first precious images from the surface, haunting. These brave missions, unfortunately, didn't last long. The intense heat and crushing pressure quickly destroyed them, sometimes in less than an hour, their delicate instruments succumbing rapidly to the hostile environment. Glimpse of this distant world's harsh, uncompromising beauty a triumph of engineering and human curiosity. Later missions from NASA and the European Space Agency have meticulously mapped Venus using advanced radar technology. Since optical imaging is nearly impossible through its impenetrable, perpetually thick clouds, radar was the only way to pierce the veil and see what lay beneath. These radar maps were crucial, revealing vast plains, towering highland regions, and enormous volcanoes, some of the largest, most majestic volcanic structures in the entire solar system. There's even compelling evidence that Venus might still be geologically active deep beneath its toxic skies. Faint tremors, subtle lava flows, and shifting surface features suggest that it may still be rumbling and reshaping itself, a silent, fiery dance of internal forces, hinting at a dynamic interior. One particularly fascinating and enigmatic feature of Venus is its tesserae. These are highly deformed, complex regions of crust that look like intricately wrinkled, crumpled terrain, like a giant distorted quilt or a tessellated mosaic. These areas are unlike anything found on Earth or any other planet we know, and they hint at complex tectonic processes that are still not fully understood by scientists. While Venus doesn't exhibit the familiar plate tectonics like Earth does, it does seem to stretch, fold, and reshape itself in strange, mysterious ways. A silent, slow ballet of immense geological forces operating on scales we are still trying to comprehend. There's also been tantalizing speculation about the possibility of life, not on the infernal surface, which is utterly inhospitable to anything we know, but high in the cloud layers, where conditions are slightly less extreme. About 30 miles, 50 kilometers above the surface, temperatures and pressures become much more Earth-like, almost temperate, and the sulfuric acid clouds are less dense. In this tantalizing region, some scientists have wondered if microbial life could potentially survive, floating and thriving among the acidic clouds, perhaps encased in protective shells or with unique biochemical adaptations. It's a long shot, certainly a highly speculative possibility, but a truly tantalizing one that sparks the scientific imagination. In 2020, a team of researchers detected a gas called phosphine in Venus's atmosphere, a compound that, on Earth, is often strongly associated with biological processes. The discovery sparked enormous scientific interest and excitement across the globe, though later, more refined observations, unfortunately, cast some doubt on the initial findings, showing the difficulty and complexity of remote detection and confirming the need for direct sampling. Still, the very idea of life, even microbial, in the clouds has reignited plans for future missions to this enigmatic planet. NASA and ESA are both actively planning to return to Venus in the coming decades with ambitious, sophisticated missions like Veritas, Venus Emissivity, radio science, INSAR topography and spectroscopy, Da Vinci Plus, deep atmosphere Venus investigation of noble gases, chemistry, and imaging plus, and ESAS Envision. These advanced orbiters and atmospheric probes will meticulously study the planet's atmosphere in unprecedented detail, its mysterious surface, and search for any possible signs of past or present geological activity, as well as definitively measure atmospheric compositions. The profound hope is to finally unravel the complex, tragic history of Venus, to learn how it became so utterly, fundamentally different from Earth, despite starting with so many remarkable similarities. What cosmic fork in the road lead one twin to vibrant, teeming life and the other to a perpetually veiled, hellish landscape? The answers might hold vital clues about our own planet's future. Venus is truly a planet of profound paradoxes, a twin that isn't, a world of searing heat and crushing air, a place of impossible extremes, yet named after the Roman goddess of love and beauty. It is both mesmerizingly brilliant from afar and terrifyingly hostile up close. And yet, we, humanity, keep looking up at that brilliant morning star, that shining evening star, wondering what profound secrets it hides behind its perpetual golden veil. A testament to the universe's endless capacity for wonder and mystery. Our own blue oasis, Earth, the jewel of life, our shared, precious home. Now, at last, we arrive at Earth, our own blue marble, our precious, vibrant, floating home, and the only known oasis in the vast, dark, silent, and largely empty sea of space. It's so easy, isn't it, to overlook Earth in a grand, exciting journey through the solar system, to take its familiar presence for granted, to lose sight of its extraordinary nature amidst the daily routine. After all, we see it, feel it, breathe it every single day, intimately connected to its rhythms, its life, its beauty. But when you truly step back, when you allow your imagination to view it from the cold, distant expanse of space, perhaps from the vantage point of a lone astronaut or a passing probe, our home becomes something altogether extraordinary, a breathtaking, unique wonder, a beacon of life in the cosmic dark. Earth is the only planet we definitively know of that has liquid water on its surface, shimmering oceans that cover vast stretches, winding rivers that carve through landscapes, tranquil lakes that mirror the sky, and even subterranean aquifers. It possesses a perfectly balanced, oxygen-rich atmosphere, a delicate, invisible veil that not only allows us to breathe, but also protects us from harsh solar radiation and dangerous cosmic rays, acting as a crucial shield. And, most miraculously of all, it cradles a biosphere bursting with life, an intricate, vibrant, and incredibly diverse tapestry of living things, from the smallest microbe to the largest whale, interconnected in a grand, evolving network. As far as we can tell from our limited vantage point in the universe, it's the only planet in the entire cosmos that has ever written a poem, composed a symphony, baked a delicious, comforting cake, or even paused to gaze up at the night sky and wonder what the stars themselves are truly made of, and ponder its own place in the grand scheme of existence. This capacity for self-reflection and artistic expression truly sets it apart. Earth is the third planet from the Sun, a fortunate position, orbiting at an average distance of about 93 million miles, 150 million kilometers. This specific, precious distance places it perfectly within what scientists call the habitable zone, or, more whimsically and perhaps more poetically, the Goldilocks zone. It's not too hot, causing water to boil away into steam under a scorching sun, and crucially, not too cold, freezing all water into solid, inert ice. No, it's just right. Just right for water to remain liquid in all its vital forms, allowing the continuous water cycle to thrive. Just right for clouds to form, gather, and dance in the sky, bringing essential rain and snow. and just right for vast, powerful oceans to slosh endlessly across its surface, shaping continents, regulating global climate, and fostering an astonishing diversity of life. The very chemistry of life as we know it depends on liquid water, making this a pivotal characteristic. Our beloved planet is approximately 7,900 miles, 12,700 kilometers in diameter, a substantial rocky world with a complex internal structure. And, like a cosmic onion, it is made up of distinct, fascinating layers. There's a solid inner core, scorching hot, but held rigid by immense pressure from above. A liquid outer core, churning and flowing, composed mainly of molten iron and nickel, generating our planet's powerful, protective magnetic field, the magnetosphere, a thick, semi-solid mantle that makes up most of Earth's volume, slowly convecting like thick syrup. And finally, a relatively thin, delicate crust, a mere eggshell, only a few tens of miles thick, upon which we live, where all our human stories unfold. But even that seemingly solid, stable crust is constantly, subtly moving beneath our feet. Earth's surface is broken into giant, interlocking pieces called tectonic plates that slowly, imperceptibly, yet powerfully shift, grind, collide, and drift over vast spans of geological time, moving mere centimeters a year, about as fast as your fingernails grow. These slow, powerful movements are the grand architects of our world, majestically creating towering mountain ranges like the Himalayas that reach for the sky, triggering sudden, sometimes devastating, rumbling earthquakes along fault lines, and fueling fiery, awe-inspiring volcanoes that release Earth's inner heat and gases. It is the dynamic, ever-reshaping dance of a planet that absolutely refuses to sit still. A living, breathing, geologically active entity. Unlike our rocky inner neighbors, the arid, sun-baked Mercury and the fiery, suffocating Venus, Earth boasts a remarkably active, intricate, and vibrant climate system. Our atmosphere, that precious, breathable mix of about 78% nitrogen, 21% oxygen, and small but vital amounts of argon, carbon dioxide, and other trace gases, performs countless vital roles that enable and sustain life. It acts as a multi-layered protective shield, guarding all life from harmful solar, ultraviolet radiation and dangerous cosmic rays originating from deep space. It expertly traps just enough heat through a natural greenhouse effect to maintain stable, comfortable temperatures across the globe, preventing extreme swings between scorching day and freezing night that would render the planet uninhabitable. And crucially, it allows water to cycle seamlessly through evaporation, condensation, precipitation, rain, snow, and runoff into rivers and oceans, ensuring the continuous flow and availability of this absolutely essential element for life. Weather, while sometimes inconvenient, especially when you're caught in a sudden downpour in Multan and forget your umbrella, or battling a dust storm, is not merely a nuisance. It is an absolutely vital, dynamic part of Earth's complex, beautiful, self-regulating life support system, constantly redistributing energy and moisture around the globe. And speaking of water, Earth is a true watery wonderland, a brilliant blue jewel in space. Approximately 70% of its magnificent surface is covered by oceans, seas, lakes, and rivers. A vast, interconnected network of liquid water flows across the land, carving canyons and nourishing ecosystems. It freezes into majestic glaciers and polar ice caps. It evaporates into the atmosphere, forming clouds, and then falls again as rain or snow in an elegant, continuous, life-sustaining loop known as the hydrologic cycle. This sheer abundance of liquid water is a cornerstone of what makes Earth so utterly unique, so vibrant, so utterly alive. Water acts as an incredible thermal buffer, gently moderating our global climate, preventing extreme temperature fluctuations, and it fundamentally sustains the unbelievably complex, interconnected web of life that thrives here, from the depths of the ocean to the highest mountains, from scorching deserts to frozen tundras. But Earth's most defining feature, the very thing that sets it apart from any other known planet in our vast universe, is, of course, life itself. From microscopic bacteria clinging stubbornly to the inside of thermal vents deep in the ocean floor, thriving in superheated, chemical-rich environments, to towering redwoods that pierce the very sky, forming ancient, majestic forests, to migratory whales singing ancient, haunting songs in the deep blue, navigating vast oceans. Earth absolutely teems with a dizzying array of organisms that have adapted and evolved to every conceivable niche, every extreme environment imaginable. There are creatures that glow in the dark, illuminating the abyssal deep sea, plants that ingeniously eat insects to supplement their diet, and fungi that can astonishingly survive and even thrive in radiation zones, defying all expectations of life. Life here is resilient, bizarre, endlessly creative, and profoundly interconnected, a testament to the planet's nurturing power and the sheer adaptability of living things. And among all those incredible, diverse organisms is one particular species, us, human beings, who somehow, miraculously, by some evolutionary twist, figured out how to build telescopes to gaze into the cosmic abyss, how to launch rockets, to touch the edges of space, and how to ask those wonderfully big, profound questions. Questions like, where did we come from, and what is our purpose? And are we alone in this vast, silent universe? And, perhaps, amidst the profound, equally pressing questions like, is there any chocolate left in the cupboard? Questions that are equal parts cosmic profundity and, well, everyday snack-related concern, demonstrating our uniquely human blend of wonder and practical needs. The moon, time, and our place in the cosmos, a delicate balance, a shared journey. Earth's steadfast companion, the moon, plays a surprisingly important and often overlooked role in all of this. Our moon is relatively large compared to our planet, with a diameter of about 2,159 miles, 3,474 kilometers, making it unusually large for a planetary satellite. And it performs a truly critical service. It helps stabilize the tilt of our planet's axis. That precise tilt of approximately 23.5 degrees relative to its orbit around the Sun, you see, is directly responsible for our beautiful, predictable, and life-sustaining seasons. Without the moon's powerful gravitational influence, acting as a gravitational anchor, Earth's tilt might wobble wildly and unpredictably over vast spans of time, leading to drastic, chaotic climate changes that would render our planet far less stable, far less predictable, and quite possibly far less hospitable to the delicate dance of life as we know it. The moon also profoundly controls the tides, that familiar, rhythmic ebb and flow of our oceans, pulling at Earth's vast waters with its subtle yet powerful gravity, a rhythm that has shaped coastlines, influenced marine life, and even human cultures and migrations for billions of years. And, of course, Earth spins. It completes one full rotation on its axis, approximately every 24 hours, a fundamental rhythm that gives us our familiar, comforting cycle of day and night, light and shadow, activity and rest. This consistent spin creates a stable environment for life. At the same time, it gracefully orbits the sun, completing one full journey around our star every 365.25 days. Hence, the clever, practical need for leap years, which kindly tidy up that pesky spare quarter day every 4 years, ensuring our calendars remain in precise sync with our planet's grand cosmic dance around the sun. The journey around the sun isn't a perfect circle either. Earth's orbit is slightly elliptical, meaning we're a tiny bit closer to the sun in January, when it's winter in the northern hemisphere, and a bit farther away in July, when it's summer. But don't worry, the seasons are caused far more profoundly by the tilt of Earth's axis relative to its orbital plane than by our precise distance from the sun. Summer happens when your hemisphere is tilted toward the sun, receiving more direct and concentrated sunlight bathed in its warmth, and winter when it tilts away, receiving less direct light. Regardless of how far Earth happens to be from the fiery center of our system, it's all about that tilt. Now, let's not pretend that our beautiful Earth is utterly perfect, a flawless paradise without challenges. It's a little chaotic at times, full of raw, untamed, magnificent energy. The immense power of hurricanes swirling across vast oceans. The sudden, ground-shaking jolt of earthquakes reshaping continents. And the fiery majesty of volcanic eruptions releasing Earth's inner heat constantly remind us that our planet is both incredibly beautiful and wonderfully volatile, alive with its own ancient, powerful forces. These are natural processes, part of Earth's dynamic nature. However, human activity, particularly over the past 2 centuries since the Industrial Revolution, the accelerating pace of climate change, driven by greenhouse gas emissions, the pervasive reach of pollution impacting our air, water, and soil, and the tragic, rapid loss of biodiversity across our ecosystems, threatening the intricate web of life that sustains us all. But still, even in the face of these formidable problems, Earth continues to be astonishingly generous, resilient, and utterly awe-inspiring in its capacity to sustain life. There's also something deeply poetic and humbling about Earth's virtual invisibility from most of the sprawling solar system, from our closest neighbors, Mercury, Venus, and Mars. Earth can appear as nothing more than a bright, distant star, a sparkling point of light in their night sky, or its bustling cities filled with the sounds of laughter and dreams, from the colossal gas giants like Jupiter and Saturn, and especially from the icy reaches beyond. Our magnificent world fades into nothing more than a tiny, almost imperceptible, pale blue dot. When the Voyager 1 spacecraft, launched decades ago, far beyond the orbit of Neptune and even Pluto, turned its cameras back at its distant home and captured that infamous image, a tiny, fragile blue speck suspended in a single, vast sunbeam. Carl Sagan, with profound wisdom and tenderness, called it the pale blue dot. This image and phrase serve as a powerful, enduring reminder of just how fragile, how precious, indifferent sea of space. It's a deeply humbling realization, isn't it? To understand that everything you've ever known, every person you've ever loved, every meal you've ever eaten, thing happened right here on this tiny, spinning speck, this cosmic grain of sand, in the immense, empty void. Earth is not just a planet. It is, in the deepest, most fundamental sense, our only known home. It is a world where fundamental atoms, forged in the hearts of distant, ancient stars, gathered into complex molecules, and those molecules, somehow, miraculously, by some unknown cosmic alchemy, became living cells. Humble beginning, somehow, out of all that cosmic dust and biological wonder, came music and stories and dreams, art and science, love and sorrow, compassion and conflict. This capacity for self-reflection, artistic expression, scientific inquiry, and complex social structures truly sets it apart. From the detached, profound perspective of space, Earth has no artificial borders, no divisive political lines, no clamoring noise of human conflict, just swirling, majestic clouds, deep blue, life-giving oceans, and vast, shifting, brown and green land masses drifting serenely across its surface. Astronauts who have had the immense privilege of seeing Earth from orbit often speak of a profound, transformative shift in their perspective, a sudden, overwhelming realization that our differences, our quarrels, our distinctions shrink to utter insignificance when viewed from that cosmic vantage point. They understand with crystal clarity that we are all simply passengers on the same fragile vessel, sailing together through the boundless, mysterious cosmos, sharing this one extraordinary home. So, as you lie there, dear friend and fellow traveler, listening, breathing gently, let yourself truly feel the profound pull of Earth, not just its familiar gravity that holds you to your bed, but its deep, comforting, living presence. You are made of the very same fundamental elements as this planet: carbon, oxygen, nitrogen, and iron, borrowed from its ancient dust and the stardust from which it formed. You are inextricably part of its grand, unfolding story, woven into its intricate ecosystems, warmed by its life-giving sunlight, and cradled by its powerful, protective, magnetic field that shields us from harmful solar winds and cosmic radiation. And as the Earth spins beneath the countless, twinkling stars, quietly, faithfully, a silent, tireless guardian, it continues to shelter us, to nourish us, and to whisper timeless stories of its ancient oceans and its slowly drifting continents. It is, in every sense, our mother world, our irreplaceable sanctuary, a testament to the universe's capacity for complex, vibrant existence. Rest easy, dear friend, knowing that beneath you, cradling you, is a living planet, teeming with wonder, vibrant with life, and that above you, the stars still shine, distant, yes, but never truly out of reach for a curious, dreaming mind that dares to wander among them. The next leg, Mars, the red planet, a whisper of possibility. Now we journey outward from the life-sustaining embrace of Earth, across the vast emptiness of interplanetary space, to our next neighbor, red and dusty orange, under a pale pink sky. This is Mars, often called the red planet, a world that has captivated human imagination for centuries, inspiring countless stories of alien civilizations and daring future expeditions. It's a distant, colder cousin to Earth, smaller and drier, yet holding tantalizing clues of a warmer, wetter past, a whispered possibility of life. Distance of about 142 million miles, 228 million kilometers. It's roughly half the size of Earth, with a diameter of about 4,212 miles, 6,779 kilometers. If Earth is our bustling metropolis, Mars is a quiet, windswept desert outpost. Its reddish hue comes from iron oxides in its soil, essentially rust. Lots and lots of rust. Unlike Earth, with its robust atmosphere, Mars has a very thin atmosphere, primarily composed of carbon dioxide, about 95%, and it's too tenuous to trap much heat. As a result, Mars is a cold place. Average temperatures hover around -80 degrees Fahrenheit, -62 degrees Celsius, though they can reach above freezing at the equator during summer daytimes, and plummet to a frigid -220 degrees Fahrenheit, -140 degrees Celsius at the poles in winter. The surface of Mars is a geological wonderland, scarred by a long history. It's covered in craters, vast plains, ancient volcanoes, and deep canyons. Among its most striking features are Olympus Mons, the largest volcano in the solar system, and the vast canyon system known as Valles Marineris, which stretches over 2,500 miles, 4,000 kilometers, long enough to span the entire United States. Mars is much less active today than Earth. Perhaps the most compelling aspect of Mars is the strong evidence that it once had liquid water flowing on its surface. Images from orbiters show vast ancient riverbeds, deltas, and floodplains, suggesting a time when Mars might have been a much warmer, wetter world, perhaps with a thicker atmosphere. Today, most of Mars's water is locked up in polar ice caps, a mix of water ice and frozen carbon dioxide, and in permafrost beneath the surface. However, there are intriguing signs of seasonal liquid water flows down crater walls, though these are likely briny, temporary flows. The quest for water and for past or present signs of microbial life drives much of the scientific exploration of Mars. Mars has two small, irregularly shaped moons, Phobos and Deimos. They are believed to be captured asteroids rather than formed alongside Mars, and they zip around the planet in peculiar, fast orbits. Phobos, the inner moon, is slowly spiraling inward and is predicted to either crash into Mars or break apart to form a ring in tens of millions of years. Deimos, the outer moon, is gradually drifting away. They are stark, rocky companions to the red planet. A day on Mars is remarkably similar to an Earth day, lasting about 24 hours and 37 minutes. This familiar rhythm makes the idea of future human missions slightly more comfortable from a biological standpoint. A Martian year, however, is much longer, lasting about 687 Earth days, almost twice as long as an Earth year. This means seasons on Mars are also much longer and more extreme due to its elliptical orbit. Giant dust storms are a common and dramatic feature of the Martian climate. These storms can grow to encompass the entire planet, obscuring the surface from view for months. Whipped up by the planet's thin atmosphere and vast plains, humanity's exploration of Mars has been extensive and continues to be a cornerstone of space exploration. From the early Mariner flybys to the Viking landers in the 1970s, the first to land successfully, to the numerous rovers like Sojourner, Spirit, Opportunity, Curiosity, and Perseverance, we have sent a fleet of robotic explorers. These rovers have drilled into rocks, analyzed soil, confirmed the presence of ancient water, and even conducted the first powered flight on another planet with the Ingenuity helicopter. Every mission has brought us closer to understanding whether Mars could have harbored life in the past, or if it might even harbor microbial life beneath its surface today. The current rover, Perseverance, is collecting samples of Martian rock and soil that are intended to be brought back to Earth by future missions, allowing us to study them in sophisticated labs. Mars is a world of stark beauty and profound questions. It represents our next great leap in space exploration, a potential stepping stone for human colonization, a place where we might one day establish a permanent presence. Its quiet, dusty plains whisper of ancient rivers and the tantalizing possibility that life in some form once stirred there. As we drift away from this rust-colored world, imagine the footprints of future explorers venturing across its cold, silent sands, guided by the very stars you see. Journey to the giants, the asteroid belt, a field of cosmic debris now. We leave the familiar inner, rocky planets behind and venture into the vast expanse of the asteroid belt. Imagine a cosmic junkyard, a colossal, dusty ring of irregularly shaped rocks and rubble, orbiting the Sun between Mars and Jupiter. It's not quite the crowded, dangerous obstacle course that science fiction movies often depict, but rather a sparsely populated, enormous donut-shaped region, a relic from the early days of our solar system. The asteroid belt is located approximately 2.2 to 3.2 astronomical unit from the Sun, where 1 astronomical unit is the distance from Earth to the Sun. This immense region is home to millions of asteroids, ranging in size from tiny pebbles to dwarf planets. The vast majority are small, no bigger than a car. However, some are enormous, like Ceres, the largest object in the belt, which is also classified as a dwarf planet, about 590 miles, 950 kilometers in diameter, large enough to be spherical due to its own gravity. Other major asteroids include Vesta, Pallas, and Hygiea. Scientists believe the asteroid belt is made up of material that never quite managed to form a full-sized planet. Early in the solar system's history, the strong gravitational influence of Jupiter, the colossal gas giant next door, prevented these countless chunks of rock and dust from accreting into a single cohesive body. Instead, they were flung about, collided, and eventually settled into this vast, orbiting ring. It's like a cosmic construction site where the building materials were left scattered rather than assembled, despite the vast number of asteroids. The total mass of the entire asteroid belt is surprisingly small, less than the mass of Earth's moon. This means the individual asteroids are spread out over enormous distances. If you were flying a spaceship through the belt, the chances of actually hitting an asteroid are incredibly slim. Most images you see are artists' renditions. In reality, you'd likely see nothing but distant stars for a long, long time, occasionally passing by a solitary rock Asteroids are incredibly diverse. Some are rich in carbon C-type asteroids, some are stony S-type, and others are metallic M-type, containing significant amounts of iron and nickel. Studying these variations helps scientists understand the different types of materials that were present in the early solar system, acting like fossilized clues from cosmic infancy. The asteroid belt isn't entirely static. Collisions do still happen, albeit rarely, and these can sometimes send fragments hurtling towards the inner solar system, occasionally reaching Earth. These meteorites are precious samples of primordial solar system material, offering direct evidence of the conditions that existed billions of years ago. Long before planets fully formed, humanity has sent several spacecraft through the asteroid belt: Pioneer 10 and 11, and Voyager 1 and 2. All traversed the belt without incident on their way to the outer solar system. More recently, the Dawn spacecraft orbited both Vesta and Ceres, providing unprecedented close-up views and data. Dawn revealed that Ceres might have a subsurface ocean and even cryovolcanoes, hinting at ongoing geological activity fueled by water ice, making it a surprisingly dynamic world. The asteroid belt serves as a quiet, dusty boundary, separating the warm, rocky inner planets from the colossal, icy gas giants beyond. It's a reminder of what might have been a collection of failed planets, yet invaluable in its scientific secrets. As we pass through this scattered field, imagine the silent, ancient rocks endlessly circling their star, carrying within them the very building blocks of worlds, waiting for us to decipher their stories. King of planets, Jupiter, the solar system's gentle giant, leaving the dusty remnants of the asteroid belt, we are now truly venturing into the realm of giants, and first among them, the magnificent Jupiter. Imagine a colossal swirling marble of orange, brown, and cream, dotted with storms so vast they could swallow Earth whole. This is Jupiter, the undisputed king of our solar system, a planet so immense it barely needs to orbit the Sun. In fact, the Sun and Jupiter actually orbit, a point between them just outside the Sun's surface. Jupiter is a world of majestic scale, immense power, and perpetual dizzying motion. Jupiter is the fifth planet from the Sun, orbiting at an average distance of about 484 million miles, 778 million kilometers. It is by far the largest planet in our solar system, so enormous that its mass is more than twice the mass of all the other planets combined. You could fit over 1,300 Earths inside Jupiter. If Jupiter were much larger, perhaps 80 times more massive, it might have ignited into a star itself, creating a binary star system with our Sun. But it just missed that cosmic threshold. Jupiter is a gas giant, meaning it has no solid surface like Earth. Instead, it's primarily composed of hydrogen and helium, much like the Sun, though with traces of other gases like methane and ammonia. As you descend into Jupiter's atmosphere, the gases become denser and denser, eventually transitioning into liquid metallic hydrogen, an exotic state of matter where hydrogen behaves like a metal capable of conducting electricity. This vast ocean of metallic hydrogen is believed to generate Jupiter's incredibly powerful magnetic field, which is about 20,000 times stronger than Earth's. This magnetic field creates intense radiation belts around Jupiter, a hazardous environment for any visiting spacecraft. The most iconic feature of Jupiter is its Great Red Spot, a colossal, persistent storm system that has been raging for at least 350 years, and possibly much longer. This anticyclonic storm is larger than Earth itself, a swirling vortex of reddish clouds. But the red spot isn't the only storm. Jupiter's atmosphere is a constant carnival of swirling clouds, powerful jet streams, and countless smaller storms, creating those mesmerizing bands of color that make it look like a painted sphere. These bands are caused by differences in temperature, composition, and dynamics within the fast-moving atmospheric currents. Jupiter has a family of at least 90 known moons, a miniature solar system unto itself. The four largest, known as the Galilean moons, discovered by Galileo Galilei in 1610, are worlds of immense scientific interest. Io is the most volcanically active body in the solar system, constantly reshaped by tidal forces from Jupiter. Europa is thought to harbor a vast, salty ocean beneath its icy crust, a leading candidate for extraterrestrial life within our solar system. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury, and it's the only moon known to have its own magnetic field. Callisto is a heavily cratered, ancient world, a fossil record of the early solar system. These moons offer a diverse range of environments, some of them potentially habitable. Jupiter spins incredibly fast on its axis, completing a rotation in just under 10 hours. This rapid spin causes the planet to bulge slightly at its equator and contributes to the strong jet streams and banded appearance of its atmosphere. A year on Jupiter, however, is a leisurely 11.8 Earth years as it slowly makes its grand circuit around the Sun. Humanity has explored Jupiter with several robotic missions. Pioneer 10 and 11 performed early flybys, followed by the Voyager 1 and 2 probes, which revealed incredible details of Jupiter and its moons. The Galileo mission orbited Jupiter for 8 years, studying its atmosphere and moons extensively, even dropping a probe into the Jovian atmosphere. More recently, NASA's Juno mission has been orbiting Jupiter since 2016, performing close flybys over its poles, providing unprecedented data on Jupiter's interior, magnetic field, and polar auroras. Future missions, like ESA's JUICE Jupiter, Icy Moons Explorer, and NASA's Europa Clipper, are planned to focus specifically on Jupiter's icy moons and their potential for life. Jupiter acts like a powerful cosmic vacuum cleaner, using its immense gravity to protect the inner solar system by sweeping up or deflecting many comets and asteroids that might otherwise pose a threat to Earth. It's a silent protector, a majestic guardian. As we drift away from this colossal gas giant, imagine its swirling storms, its colossal magnetic field, and its silent, enigmatic moons, each a world unto itself. Jupiter, the benevolent king, reminds us of the sheer scale and raw power that the universe holds, the jewel of the solar system. Saturn, the ringed beauty from the grand presence of Jupiter. We move gently outward to its closest neighbor, the breathtaking Saturn. Imagine a world of serene golden hues, adorned with an ethereal, impossibly thin, yet vast system of shimmering rings that appear to float around it like a cosmic halo. This is Saturn, undoubtedly the most visually stunning planet in our solar system, a true jewel of the cosmos. It inspires awe and wonder with its elegant, silent dance. Saturn is the sixth planet from the Sun, orbiting at an average distance of about 886 million miles, 1.4 billion kilometers. It is the second largest planet in our solar system, with a diameter of about 72,370 miles, 116,460 kilometers, almost 9.5 times the size of Earth. You could fit 760 Earths inside Saturn. Like Jupiter, Saturn is a gas giant composed primarily of hydrogen and helium with a small, rocky core. It is the least dense planet in the solar system, so light, in fact, that if you could find a bathtub large enough, Saturn would actually float. The defining feature of Saturn is, of course, its magnificent ring system. These aren't solid rings, but rather countless billions of tiny particles, ranging in size from specks of dust to house-sized boulders, all made mostly of water ice with some rocky material. These particles orbit Saturn like miniature moons, arranged into thousands of individual ringlets, so thin that if you scaled them down, they would be thinner than a razor blade. The rings span an incredible 175,000 miles, 282,000 kilometers across, yet are only about 30 feet 10 meters thick in most places. The origin of Saturn's rings is still a subject of scientific debate, but current theories suggest they may have formed from the breakup of a small icy moon or comet that got too close to Saturn's immense gravitational pull. Saturn's atmosphere, while similar in composition to Jupiter's, is much calmer and more subtle in its banding, largely hidden by a haze of ammonia crystals in its upper atmosphere. Nevertheless, powerful winds whip around Saturn, especially at its equator, reaching speeds of over 1,100 miles per hour, 1,800 kilometers per hour, making them some of the fastest winds in the solar system. Occasionally, massive, transient storms can erupt in its atmosphere, visible as large white spots, but these are less common and less persistent than Jupiter's Great Red Spot, like Jupiter. This rapid rotation, combined with its low density, causes Saturn to be noticeably flattened at its poles and bulging at its equator. A year on Saturn, however, is a much longer, more patient journey, lasting about 29.5 Earth years. Saturn has a truly incredible family of moons, with at least 146 known moons, more than any other planet in the solar system. After Jupiter's Ganymede, and is unique for having a dense atmosphere even thicker than Earth's. This atmosphere is rich in nitrogen and contains clouds and rain, of methane flowing into rivers and lakes of liquid hydrocarbons. It's a world strikingly similar to early Earth, just much, much colder. Enceladus is a small, icy moon that continuously sprays plumes of water vapor and ice particles into space from its south pole, indicating a subsurface ocean of liquid water. Warmed by tidal forces, one side incredibly dark and the other very bright, and a mysterious equatorial ridge that makes it look like a walnut. Mimas is often called the Death Star Moon due to its enormous impact crater, Herschel, which makes it eerily resemble the fictional space station from Star Wars. Humanity has had several robotic encounters with Saturn. Pioneer 11 performed the first flyby in 1979 of its rings and moons. But the most significant mission was Cassini-Huygens, a joint NASA-ESA-ASA-ASA mission that orbited Saturn for 13 years. From 2004 to 2017, Cassini performed incredible feats, sending back breathtaking images and vast amounts of data, revolutionizing our understanding of Saturn, its rings, and its moons. With its mesmerizing rings and vast collection of moons, continues to be a source of endless fascination and scientific discovery. It's a world that reminds us of the breathtaking artistry of the cosmos, a silent, elegant dancer in the grand ballet of the solar system. As we slowly drift away from its golden glow and shimmering rings, imagine the countless icy particles endlessly orbiting, reflecting sunlight in a cosmic dance, holding secrets of a beautiful, mysterious world. The ice giants, Uranus, the sideways world. Now, our cosmic journey takes us even further into the chilly, mysterious outer reaches of our solar system, to the distant realm of the ice giants. First among these is Uranus, a world often described as the sideways planet due to its peculiar tilt. Imagine a pale blue-green marble, largely featureless from a distance. Ball. This is Uranus, a world of deep cold, strange seasons, and profound enigmatic beauty. Uranus is the 7th planet from the Sun. It is the 3rd largest planet by diameter, and the 4th most massive. You could fit about 63 Earths inside Uranus. Like Jupiter and Saturn, it is a giant, but it's classified as an ice giant rather than a gas giant. While it has a thick atmosphere of hydrogen, helium, and methane beneath that, this slushy, icy mantle surrounds a small, rocky core. The most striking feature of Uranus is its extreme axial tilt of about 98 degrees, almost directly at the Sun. This leads to the most extreme seasons in the solar system. For nearly a quarter of its long year, one pole faces the Sun, experiencing continuous daylight. Then, as it orbits further, the equator faces the Sun, and eventually, the roles of the poles reverse. Imagine a summer that lasts for 42 Earth years, followed by a winter of similar duration. A truly bizarre climate cycle. Uranus's atmosphere is what gives it its distinct blue-green color. Red light and reflects blue and green light. Unlike Jupiter and Saturn, Uranus appears largely featureless in visible light, though subtle cloud bands and storms have been observed in infrared. Winds on Uranus can be incredibly fast, reaching up to 560 miles per hour, 900 kilometers per hour. Despite its icy composition, Uranus is a surprisingly cold world. Cloud tops reaching as low as -371 degrees Fahrenheit, -224 degrees Celsius. This extreme cold is partially explained by a lack of internal heat radiating from its core. Unlike Jupiter and Saturn, Uranus has a complex system of 13 known rings, though they are much fainter and narrower than Saturn's. These rings are made mostly of dark, dusty particles, making them difficult to observe. The planet also boasts a family of 27 known moons, each named after characters from the works of Shakespeare and Alexander Pope. Many of these moons are small and icy, but some are particularly interesting. Miranda is a patchwork world with a chaotic, jumbled surface of cliffs, canyons, and ancient terrain. Heating and resurfacing. A day on Uranus, its rotational period, is relatively short, lasting about 17 hours and 14 minutes. This means a human lifetime might span only a small fraction of a Uranian year. putting its extreme seasonal changes into a vast, slow-motion perspective. Only one spacecraft has ever visited Uranus, NASA's Voyager 2. It flew past the planet, providing humanity's first and only close-up views of this enigmatic ice giant and its moons and rings. Voyager 2 revealed its peculiar tilt, measured its magnetic field, and discovered several new moons and rings. Since then, all our observations of Uranus have been made from Earth-based telescopes, or the Hubble Space Telescope. There are currently no missions specifically planned to orbit Uranus. Its peculiar tilt and extreme cold hinting at a violent past collision. Blue-green giant rolling through the darkness of the outer solar system. Outpost Neptune, the windiest world, our final planetary destination, dear traveler, takes us to the very edge of the recognized major planets, to the most distant of the ice giants, Neptune. Imagine a deep, vibrant blue sphere, swirling with furious dark storms and streaked with bright, wispy clouds, a truly tumultuous world, despite its immense distance from the Sun. This is Neptune, the windiest planet in our solar system, a cold, majestic outpost in the sunless outer reaches. Neptune is the 8th and farthest known planet from the Sun. Orbiting at an incredible average distance of about 2.8 billion miles, 4.5 billion kilometers, it is slightly smaller than Uranus, but more massive, making it the 4th largest planet by diameter and the 3rd most massive. You could fit about 58 Earths inside Neptune. Like Uranus, Neptune is classified as an ice giant, meaning it's primarily composed of a superhot, dense fluid mixture of water, ammonia, and methane ices, surrounding a small, rocky core. Neptune's striking deep blue color is also due to the presence of methane in its atmosphere, which absorbs red light. However, Neptune is a more dynamically active planet than Uranus, showing more prominent atmospheric features. When Voyager 2 visited in 1989, it observed a prominent feature known as the Great Dark Spot, a huge anticyclonic storm similar to Jupiter's Great Red Spot, though it later disappeared. Other bright, rapidly changing cloud features were also seen, indicating a very active and turbulent atmosphere. The most astonishing feature of Neptune's atmosphere is its winds. These are the fastest planetary winds in the entire solar system, reaching incredible speeds of over 1,200 miles per hour, 2,000 kilometers per hour, even faster than the speed of sound on Earth. These supersonic winds whip around the planet, driving its storms and cloud features, despite being so far from the Sun and receiving very little solar energy. Neptune seems to have an internal heat source that drives its vigorous atmospheric activity. A mystery scientists are still working to understand. Neptune is incredibly cold, with atmospheric temperatures similar to Uranus, around -360 degrees Fahrenheit, -218 degrees Celsius. Sunlight at Neptune's distance is approximately 900 times fainter than on Earth, a perpetual twilight, almost true darkness. Neptune has a faint, fragmented ring system made of dark, dusty material, similar to Uranus's, but even less prominent. It also has 14 known moons, the most significant being Triton. Triton is Neptune's largest moon and is one of the most fascinating objects in the outer solar system. It's unique because it orbits Neptune in a retrograde direction, opposite to Neptune's spin, suggesting it was likely a captured object from the Kuiper Belt, rather than forming with Neptune. Triton is incredibly cold, with surface temperatures as low as -391 degrees Fahrenheit, -235 degrees Celsius, making it one of the coldest places in the solar system. Despite this, Voyager 2 discovered active cryovolcanoes on Triton, spewing plumes of nitrogen gas and dust particles high into its thin atmosphere, indicating geological activity powered by internal heating or solar warming of subsurface ice. A day on Neptune is relatively short, lasting about 16 hours and 6 minutes. However, its orbit around the Sun, is truly immense, a staggering 165 Earth years. This means that since its discovery in 1846, Neptune has only completed one full orbit around the Sun. Like Uranus, Neptune has only been visited by a single spacecraft, NASA's Voyager 2, after its encounters with Jupiter, Saturn, and Uranus. Voyager 2 made a historic flyby of Neptune in 1989, providing our only close-up images and data of this distant world. It revealed Neptune's dynamic atmosphere, its great dark spot, its rings, and its fascinating moon Triton. Since Voyager 2, all our knowledge of Neptune has come from powerful Earth-based telescopes and the Hubble Space Telescope. As with Uranus, scientists are advocating for a future dedicated mission, perhaps an ice giant orbiter that could visit both Uranus and Neptune to unlock more of their secrets. Neptune, named after the Roman god of the sea, is a world of fierce winds, deep blues, and profound mysteries. It stands as a sentinel at the outer edge of our planetary system, a cold, dynamic giant that challenges our understanding of how planets form and behave in such extreme environments. As we now prepare to drift even further beyond the known planets, imagine Neptune's silent, distant dance, its turbulent atmosphere hiding secrets from the sun's faint light, a vibrant blue beacon in the cosmic twilight. Beyond the planets, the Kuiper Belt, and the far reaches, our journey through the solar system doesn't quite end with Neptune. Beyond the last major planet lies a vast, mysterious region known as the Kuiper Belt. Imagine a second, much larger asteroid belt, but instead of mostly rocky objects, this one is filled with countless icy bodies, remnants from the early days of the solar system, frozen in time. The Kuiper Belt extends from about 30 astronomical units, Neptune's orbit, out to about 50 astronomical units from the Sun. It's home to millions of icy objects, often referred to as KBO's Kuiper Belt objects, ranging in size from tiny specks of dust and ice to dwarf planets larger than Pluto. This region is thought to be the source of many of the short-period comets that occasionally visit the inner solar system, their icy bodies gradually nudged inward by the gravitational pull of the gas giants. The most famous resident of the Kuiper Belt is, of course, Pluto. Once considered the 9th planet, Pluto was reclassified as a dwarf planet in 2006, part of a new category of objects that meet some, but not all, of the criteria to be a major planet. It hasn't cleared its neighborhood of other objects. Pluto is a fascinating, icy world, smaller than Earth's moon, with a heart-shaped glacier, towering mountains of water ice, and a thin nitrogen atmosphere that sometimes freezes and falls as snow. It also has 5 moons, the largest of which is Charon, so massive that Pluto and Charon often orbit a common center of gravity. almost like a binary dwarf planet system. Other notable dwarf planets in the Kuiper Belt include Haumea, a rapidly spinning, oblong object with rings, Makemake, one of the largest KBOs, covered in frozen methane and ethane, and Eris, which is even more massive than Pluto. These distant worlds are true ice worlds, preserving the primordial materials from which our solar system formed. Only one spacecraft has ventured far enough to explore the Kuiper Belt in detail: NASA's New Horizons probe. After a remarkable 9-year journey, New Horizons performed a historic flyby of Pluto in 2015, providing humanity's first close-up images of this distant dwarf planet. The mission then continued deeper into the Kuiper Belt, performing a flyby of a small KBO called Arrokoth, formerly Ultima Thule, in 2019, revealing it to be a unique bilobed contact binary, two objects that gently merged. New Horizons continues its journey into the interstellar medium, sending back data on the conditions in the farthest reaches of our solar system. The Kuiper Belt represents the vast cold frontier of our solar system, a region that holds countless clues about its formation and evolution. It is a silent, frozen archive of cosmic history, where icy relics drift in a slow, perpetual dance, illuminated only by the impossibly faint glow of our distant sun. The Oort cloud, the solar system's final frontier, and finally, beyond even the Kuiper Belt, stretching out into the truly vast, empty darkness, lies the Oort cloud. Imagine a colossal, spherical shell of icy debris, surrounding our entire solar system like a colossal, diffuse bubble. This is the ultimate cosmic frontier, the true edge of our sun's gravitational dominance, so far that the sun would appear as merely a very bright star, indistinguishable from countless others. The Oort cloud is believed to extend from about 2,000 to 100,000 O from the sun. That's almost a quarter of the way to the nearest star. It is thought to contain trillions of icy bodies, primordial remnants from the formation of our solar system. These objects are so far apart that collisions are incredibly rare. This immense distant reservoir is believed to be the source of comets, those celestial visitors that plunge into the inner solar system from seemingly nowhere, often with spectacular tails, on orbits that can last thousands or even millions of years. These comets are believed to be gravitationally nudged out of the Oort cloud by passing stars or the gravitational tides of the Milky Way galaxy itself. They are frozen time capsules, preserving the original composition of the solar nebula from which our sun and planets were born. The Oort cloud is entirely hypothetical. It has never been directly observed, as its objects are too small and too far away to be seen even with our most powerful telescopes. Our understanding of it comes from mathematical models and the study of comets. It represents the gravitational boundary of our solar system, where the sun's influence finally fades into the gravitational pull of the wider galaxy. No spacecraft has ever reached the Oort cloud, and none will for many centuries, if ever, given the immense distances and time scales involved. The Voyager probes, currently traveling through the interstellar medium, are still many thousands of years away from truly exiting the Oort cloud. It remains a realm of pure speculation and profound mystery, a testament to the sheer scale of our solar system and the universe beyond. Our journey, dear traveler, has brought us from the fiery heart of our sun past the scorched and shrouded inner worlds, across the dusty asteroid belt, through the magnificent realms of the gas and ice giants, and finally to the distant, icy frontiers of the Kuiper Belt and the hypothetical Oort cloud. Each planet, each moon, each asteroid, each comet is a unique world with its own story, its own secrets, and its own place in the grand cosmic tapestry. You have voyaged across billions of miles, witnessed unimaginable temperatures and pressures, contemplated the vastness of time and space, and perhaps, just perhaps, caught a glimpse of the sheer wonder and diversity of our universe. As we now slowly, gently return to the familiar comfort of Earth, let these cosmic stories settle within your mind. The universe is a vast, beautiful, and mysterious place, full of things to learn and wonders to behold. Now, let your breath grow even softer. Feel the gentle pull of Earth beneath you. The stars, those distant suns, are still shining, countless stories waiting to be told. But for now, your journey through our solar system is complete. Drift off to a peaceful sleep, knowing that you are a part of this incredible cosmos, a tiny, precious inhabitant of one beautiful, pale blue dot. Sweet dreams, cosmic explorer. May your rest be as vast and serene as the universe itself.